Hi, I am Martin Sawicki, and in this session I'll be teaching you about Java development in Windows Azure. First, I'll do a quick overview of what's available, what it means, and how to get it. Then we'll walk through a very simple Hello World demo. And then, for the bulk of the session, we'll dig deeper into various advanced features and tricks that I hope will help you be successful with Java development on Azure. So what's the story? There are three things that are available for you to help you with your development. There is the Windows Azure plugin for Eclipse with Java that I will cover in detail in this session. There are the Windows Azure libraries for Java, which I will mention briefly, and you can download them from the Windows Azure Developer Center. And then there is the Developer Center itself. On a very high level, there are three aspects of Java development on Azure that I want to point out. One is the familiarity. You're going to be using Eclipse, which is the most popular IDE for Java developers, and which is the most popular build tool for Java developers, and Maven, which is a very popular build and dependency management tool. You'll see how flexible this story is. You bring your own Java server, your own JDK. You're not constrained to a specific Java server. And last, but definitely not least, it's all open source. You will find the sources for the plugin for the Java libraries on GitHub and SourceForge, all under the Apache License 2.0. Let's start off with a very simple demo of a Hello World application running in Windows Azure. Initially, I'll just do two steps. First, I'll create a Windows Azure project that will serve as the deployment vehicle for my application, and then I'll just deploy it to the Windows Azure emulator running locally on my machine and test it there. The Java application that I'm testing is a very simple dynamic web project with just a single JSP file with Hello World inside of it. Of course, your application can be a much more complex servlet. The deployment steps will be pretty much the same. So first, let me create a Windows Azure project. And I'll accept all the defaults for now. Then I need to add a few things to this project. I need to add my application. I need to add a server of my choice into the project as well. I need to add my JDK, and I'll need to describe the deployment logic of these components. The easiest way to get started is to pick from one of our sample scripts. Depending on the server that you want to use, you can pick the corresponding startup script sample, open it up, and follow the steps in the sample. First, I'll copy all these steps into the startup script of my own project, which I can find under the applet directory inside of the worker role folder. Then I'll place a JDK distribution into the applet directory as well, and my server distribution into the same location. I downloaded these distributions from the web. The applet folder is a very important folder because it contains all the things, all the components, all the pieces that you want to deploy into the cloud. And the last step is I need to add my application into this project. There is a default hello world.war file already in it, so I'll just erase that and export my own hello world into that project. So again, I need to find the applet folder and export it there. And to verify that my export actually worked, I'll refresh this directory, and I can see my file showing up there. Next, I can just rebuild. And then, inside of the Emulator Tools folder, double-click this script. This will deploy my application into the Windows Azure emulator. As the deployment is taking place, I can watch the startup steps from my startup script in real time. So that way I can see if something goes wrong in my startup logic. After a few seconds, when the Tomcat console window shows up, and also when the Windows Azure emulator UI starts reporting that my application is running, I can open a browser and navigate to localhost 8080. This will first give me the main Tomcat homepage, and I can test my application by going to Hello World, and that should show me a Hello World. So I can now see my very simple application running in the Windows Azure emulator. At this point, I could build a package and deploy it into the cloud. But before I go there, I'd like to take you on a tour of the more advanced features in the Windows Azure plugin for Eclipse, as well as in the Windows Azure libraries for Java. I've already downloaded them and put them in a folder on my desktop. You can see the main Windows Azure library here, and then the others are the dependencies from Maven. Let's say I want to now start calling some APIs from Windows Azure from within my Java project. So the first thing to do is to add these libraries to the build path of my project. Next, before I leave this dialog, I need to remember to add all of them to the deployment assembly of my project. This is one of the ways to ensure that the libraries are included inside of your deployment package. Next, to start using them from within my Java program, let me add an import directive and I'll be using some APIs from the service runtime part of the Windows Azure libraries. I will show the instance ID of the particular role that will be running. And at this point, let me export this file again into my Windows Azure project. And rebuild the project. After it's rebuilt, I'll run it in the emulator again. After the deployment process is finished, I can go back to my web page and refresh. Next, we'll take a closer look at the structure of the Windows Azure project, how the deployment logic works, and also I'll teach you a couple of tricks that will make your development a little bit easier. Let's start off by taking a closer look at the startup script. This is the script that Windows Azure executes when it initializes your deployment. If you scroll below, you will see the details of the deployment logic. You will notice that the logic actually makes a couple of calls into some other scripts that are part of your project. One of them is the unzip script. These scripts come from the utility folder inside of your AppRoot, which is included in your project out of the box. Another helpful utility script is download. Although it's not referenced directly here, if you look above at the steps here, there is an example, a commented out example that shows you how you can use the download script to download a component into your deployment at the time your deployment is initialized, as opposed to relying on it being in the original package to begin with. Now, you have to be wary that this will be downloading things from servers anytime your row instance is getting recycled. So just be aware of that. But if you, say, have a storage account in Windows Azure where you want to save some of those pieces that you want to deploy into the cloud, then certainly you could use the download script to download those if that's how you want to deploy your applications or various components. Another thing to remember about the startup script is that as soon as it completes, Windows Azure knows that your deployment is ready and it's running. So when it exits successfully, Windows Azure is going to run your application, but if it doesn't exit successfully, then Windows Azure is going to consider that a failure, and it will attempt to restart your deployment. Now let's also take a quick look at this other script included in your project, run.cmd. This one runs whenever Windows Azure actually starts your deployment. Your deployment is already running. Now, the way this script works is that it should actually never exit as long as your application is in a healthy state. Whenever it exits, Windows Azure will consider this as a request to recycle the role. So what this script has by default is a call to this useful utility, whileproc.cmd, which monitors your java.exe process. That way, if your Java goes down, that's a hint for this deployment that it should request a role recycle, and it will exit from this script. So you can customize this script with your own monitoring logic. By default, it's just monitoring java.exe. In fact, if you look at the Windows Azure emulator UI, you will see all these messages popping up. Java.exe is running. These messages are coming out of that whileproc script every 15 seconds or so. So while we're here, let me actually show you how this works in practice. Let me start the task manager, and I will end the Java process. You'll see what happens next. You will notice that the script has exited, and therefore Azure is starting to recycle the role instance. This is a very useful piece of functionality in the cloud when your deployment can fail for random reasons at any time. Let's just reset this. Now let's take a closer look at the app-root directory itself. The app-root directory is really the place where anything that you want to deploy into Windows Azure Cloud can be placed, and that ensures it will be part of the package. And also, when it's deployed into Windows Azure, it will also be located in a folder called the app-root. Other interesting files I'll just mention briefly. So package.xml is the Ant build script of your project. You can explore it inside, and I wouldn't necessarily recommend tweaking it by hand, but you can read more about it in the documentation. And then these two files, csconfig and csdev, are standard Windows Azure configuration files. And again, I would not necessarily recommend tweaking them by hand. Most of the features available in these files are already exposed in the Windows Azure Plugins UI, but certainly there are some advanced features, advanced scenarios where you might want to manually edit these files. Now, as far as the worker role folder itself goes, for every role that you define inside of your service, there is going to be a separate worker role folder. One way to think about these roles is as tiers in a multi-tier application, for example. So if you have a front tier, a middle tier, you could use different roles for each one. You can also think of a role as a cluster, so you can scale your application by increasing the number of instances of a given role. We've already looked at the samples folder, emulator tools, pretty self-explanatory. The deploy folder deserves some attention as well. Here I can actually look inside of my deployed Windows Azure project. So this is basically what the Windows Azure emulator is looking at. So to verify, for example, that your deployment logic worked, you could look here and basically see all the files that were and directories that were created as a result of your startup steps. This is another tool you can use for your troubleshooting. I'll cover the cert folder a little bit later when we talk about remote access. Now, one thing you may have noticed is that anytime I made a tweak to the Java application, I repackaged everything and redeployed. And you may be asking, is that really necessary? And no, definitely not. There are various ways of making that process much simpler. One of my favorites is to simply configure Tomcat or whatever server you're using to enable the App Manager functionality within it. JBoss, Tomcat, they all have that. So to do that in Tomcat, I'm going to need to create this permissions file, which basically gives me permissions to use the Manager UI. I'll add it to my app-root, just like any file that I want to deploy with my application. And then I need to modify the startup logic to copy that file into Tomcat. And I can just do it right here. Copy. Now, these steps are specific to Tomcat. For other Java servers, they will look a bit different. So now I'll just save and rebuild the project. And redeploy to the emulator. So when Tomcat is running, I'll just go to Tomcat's management UI. In this way, I can keep Tomcat running in the emulator as long as I don't change the Windows Azure project itself. If all I'm changing is the Java application and just redeploying a WAR file, then I can do it directly through Tomcat. I just need to keep the emulator running, basically. So in this next demo, we're going to take a look at how we can take advantage of local storage resources for larger deployments that might not fit in the app root, and how the Eclipse plugin helps us with that. Let me just right-click on the worker role, go to its properties. Inside of Windows Azure role, you will see local storage on the list here. And we can define a local storage resource. It's really simple. I'll just accept the defaults. I'll give it a bigger size. Let's say 1 GB should be enough. And make note of this environment variable. I'm actually going to copy this because I will take advantage of it in my startup script. Now, let's say that I want to put my JDK not inside of AppRoot, but inside of that local storage resource that I've created. So I just need to make 2 changes in this script. This is the first one. And this is the second one. Now, if I rebuild and redeploy, in a few seconds, you'll see the effect of doing that. You will notice in the startup console already that the unzip step is copying, or rather unzipping, jdk.zip into this long path name, which is the actual path name of that local resource. And it's known only at deployment time. That's why we cannot tell before deployment what that path is going to look like. And that environment variable helps us determine that. In this next demo, we're going to take advantage of the remote debugging configuration feature in the Eclipse plugin. This will enable you to debug your Java applications running within the Windows Azure emulator. I'll start off by putting a breakpoint on this line. Then I'll go to the worker role properties dialog. And in the debugging section, I'll just check this checkbox. It will automatically create an endpoint for me to enable the debugging. And while I'm here, I can also create a debug configuration for Eclipse so that I can more easily start debugging my projects. I just need to select the project that I'm going to be debugging. And I'm going to create a debug configuration for the emulator only. The plugin also allows us to create a configuration for the Windows Azure Cloud. I wouldn't necessarily recommend doing that in the public cloud, though, because the debugging channel is not secured, but on premises it's certainly possible. Before you can do this, though, you have to have your application already deployed, because you need to know the URL of the application. So I'll stick to the emulator for now. A new debug configuration has been added for me in Eclipse, so I'll be looking for it later when I start my debugging. Now I just rebuild and restart the emulator again. So after a few moments, when I see that Tomcat's running again, I'll start my debug configuration. I'll look for it here. Start. And next, I'm going to go to Tomcat again, to my application, And you will notice Eclipse detecting that a debug session is being initialized. And we can see we're stopped at a breakpoint in my code. And I can step through the code and do my debugging this way. But I'll just get out of this and move on to the next demo. It's time to start looking into deploying my package into the Windows Azure cloud. When we do that, we can start exploring some of the other features that are available only in the cloud, such as sticky sessions, also known as session affinity, and remote desktop connectivity. Let's go to the role properties dialog again. And there, in the load balancing section, you will notice a checkbox enables HTTP session affinity. This feature works only in the cloud, and it's applicable only when you have more than one instance of your role running, and it affects your entire role. So if you want to have one role that has sticky sessions, but you also want to have an application that doesn't have sticky sessions, you would put that in a separate role. To change the number of instances for this role, I go to the main screen for the Windows Azure role, and let's increase the number of instances, let's say to 5. Now, to build this for the cloud, I need to change a project property. So go to Project Properties this time. And in the Windows Azure section, you will see the build for setting. I'll change it for Deployment to Cloud. From now on, Eclipse will build this project so that you can upload it into the cloud and not for the emulator. Also, while we're here, let us configure remote desktop. There is a default configuration that comes out of the box, but I'll modify it. I'll specify my own password. By default, my credentials are going to be signed and encrypted with a certificate that ships as part of the plugin. This is for educational purposes only, and the password of this certificate is publicly known. So let me create a new certificate just for myself. And I need to save this certificate as a file. And now we're ready to rebuild. This time, what's being built for me is a single package file that I will be able to deploy to the Windows Azure cloud. I will find this inside of the deploy folder along with a link to the Windows Azure portal. And I will create a new hosted service. I'll select the package file that was just built for me. And the config file. Because I've enabled remote desktop, I also need to add the certificate used for remote desktop. And I saved it in the cert directory. It looks like my name is already taken, so let me do a different one. While this is uploading, let me also create another version of this deployment that does not have sticky sessions enabled so that we can compare the behavior between the two. After a few minutes, I see that some of my instances are starting to show up as ready. So first, let's take a look at the remote desktop feature that we've enabled. I'll click this connect button, accept the connection, specify the password that I set in the project, and now you can see This is basically the virtual machine that's running in the cloud that's running my application. And this is another tool that may help you troubleshoot your deployments. So for example, if I go to the E drive, I will see the app root, and this is where all my deployment components were deployed. So after a few minutes, I see that all my role instances are ready and running. While we were waiting, I also created another version of the deployment that didn't have sticky sessions enabled, just to compare the two. So first, let's take a look at what's happening with the deployment that doesn't have sticky sessions enabled. I'll go to the URL. I'll go to my application, and you will notice that each time, or almost each time, I refresh the browser, there's a different role instance returned by my application. Now, if I go to the service, to the deployment with sticky sessions enabled, and try exactly the same thing, I see role instance 1, and every time I keep reloading, it stays with the same role instance. So that's sticky sessions in action. Now, there are a number of other features that I haven't covered that you can read about in our tutorials on the Windows Azure Developer Center for Java. I'll just briefly mention them here. You can also modify the endpoints of your service, and you can also set environment variables that will be accessible to your startup script. You will find a number of helpful tutorials and other information on our website. In the meantime, I hope this demo has been helpful, and I'm looking